If you've ever wondered the difference between a Raspberry Pi and a microcontroller, this episode is for you. Today, we'll explore the difference and teach you how to program your very first microcontroller on this episode of Cyber Weapons Lab. A Raspberry Pi is designed to be incredibly beginner-friendly, and as such, it's a lot more similar to the default computer you might have worked with your entire life. Because it has an entire operating system running on it, it means that you can plug it into an HDMI cable and get started almost right away. You won't find the same kind of convenience with a microcontroller. They don't run an entire operating system. Instead, they're programmed and run the same code over and over in order to accomplish a specific function. Now, this is still incredibly useful because you can do a lot of things in the logic to make it so it can handle a lot of different types of events. Today, we're going to do something incredibly simple, which is just create an LED that blinks on and off according to a time delay that we set. Now, while this sounds simple, we're actually going to be learning a lot of different concepts when programming a microcontroller. The first will be the structure of the code. We're going to take a look at why microcontrollers are different, and why if you've programmed in C++ before, you can't just go and write a program the exact same way you would if you're just executing it on a normal computer. Also, we're going to get into hardware and how to use the pins for both input and output, so you can define each pin and then set what you want to happen when you get a particular input or want to produce a particular output on that certain pin. We'll also work a little bit with hardware on the breadboard and learn a little bit about using a resistor to prevent your LED from burning out, and put everything together in a way that hopefully won't fry it on your first try. Once you have a breadboard, an LED, and a microcontroller that's programmable in Arduino, like the Arduino Uno or the ESP8266, then we can begin. Before we get started programming, we're going to need to wire up the hardware components. Now, this is relatively simple on this occasion because we're only going to be involving an LED. So to start, we'll need an LED and also a resistor to ensure that we don't burn it out by sending it 5 volts directly. Now, the value of this resistor should be between 150 and 220 ohms, and that should protect the LED when we plug it in and prevent it from emitting a bunch of smoke rather than a bunch of light. Now, I'm going to do this in 2 different ways. The first with a setup that's really cheap and goes for about $6, and the second with a slightly more expensive but a little bit more clear setup that's about $45. Now, the latter is the STEM Terra board, and it's really cool because it basically has an Arduino Uno on the inside of it and a full unobstructed breadboard for you to connect components and do whatever you want. This is about $45, while this is just a simple breadboard, and by combining it with the Node MCU, which is using this ESP8266 chip right here, just like this D1 Mini, either one of these boards will work perfectly fine if you plug it into a normal breadboard, just like this. So when you press it in, take note of where it lines up, because you'll usually need to use a particular pin or program things for one pin on the output side here, or they're both output, but one pin on the output pins that will generally kind of decide when the LED will turn on and when it will turn off. Now, as I mentioned, it's not good practice to just directly plug this into the LED. And first, we'll need to take the LED and identify which side is power and which side is ground. Now, you might be able to see there's one lead that's a little bit longer, and this is the lead that's going to be power. So this longer lead we need to plug in, and in this case I'm going to plug it into row 4, with the shorter lead, which is ground, plugged into number 3. Now what we need to do is first plug in this resistor so that it is standing in between the voltage we want to give to this LED and the voltage that's coming from the pin. So let's go ahead and take a yellow, or whatever color you want, jumper, and we're going to plug it into D3 on this Node MCU, and then plug it into the resistor right here. Now these rows are all connected, and while these rails on the side are connected vertically, all these little rows here are connected horizontally. So what we're doing is we're taking power from pin D3, we're putting it into this side of the resistor, and then we're bringing it directly to the LED through the other side. Now, as soon as we have this done, we just need to connect the other side with another jumper to the ground pin. And after I connect it here, we can simply connect it right here on the node MCU, and then we should be ready to go. We can now program pin D3 and make this LED do pretty much whatever we want. But I'm going to set this up on the STEM Terra board so it's a little bit more clear to see, because this board has the microcontroller sitting in the middle taking up a bunch of space. So let's go ahead and take our LED and place it on the STEM Terra board with the long lead in slot 1. Then we'll take our resistor, put it also into slot 1, and offset it so we can put in the power directly. And then I'm going to go ahead and take the power from pin 3 and plug it into the same row. Now we have the power coming from pin D3 into the resistor and then into the LED. So we'll complete the path for the electricity to flow by taking the other side, plugging it into this wire, and then plugging this into ground, which is notated as GND. Great. Now that we have this all together, we should be able to program pin just 3 on the STEM Terra board, which will control the power going to the resistor and then make this LED turn on and off according to the way we program it. Now that we have our LED to start playing with, let's get started with the code. Let's go ahead and open up a new sketch. From here, we'll need to take a look at the way that writing programs for microcontrollers differ from just writing a program that you might be executing on your own computer. Now, the first thing we need to keep in mind is that we're dealing with some physical components here. We've selected pin 3 as our output pin. So one of the first things we'll need to do is define that as an output pin rather than an input pin, which might be listing for a sensor value, and then decide what we want to do with it. Now to do this, we'll need to learn about the pin mode, we'll need to learn delays, and also how functions work. But don't worry, because we'll start out pretty slow, and that's going to be with a comment that just says what this script is for. Now, you can use 2 slashes in order to create a comment, and what this is for is anybody who's going to be using your code after you, or maybe yourself later, if you don't remember exactly what it was you were up to. Now, if you have an idea, if you're trying something, or if you simply need to document your code for other people to work on later, it's essential to make sure you do this. Next, we'll need to define a couple variables, and this is important because when working with Arduino, we need to define everything before we use it. Now, we've decided that the LED is going to be connected to pin 3. So let's do a constant integer that's called LED, and we're going to make that 3. Now, what we've just done is say we want to create a variable, in this case an integer, meaning we're just going to store a number. It's going to be constant, so it's not changing. That way it won't accidentally maybe get changed by something in the script. And then we're selecting it as the number 3. Now, if I were to just print this, it would just tell us 3. But this is so far all we need to do in order to select which pin we want to use. Now, by naming it LED, that's not making it do anything special. I could name it X, I could name it something completely nonsensical. It's just a label for where we're storing, in this case, the number 3. So now we reach an important part of the script called the setup. And in the script, I'm going to go ahead and put 2 important sections right now and then fill them in after I explain them. The first is setup. And the setup section is actually a function, which I'm going to explain because they're really useful and really important, but this is a bit of an unusual one. So this is a function that is called a void function, meaning it's not expecting to return anything. And anytime you see something like this with 2 closed parentheses, that means that it is a void function. So the contrast to this would be a function that's expecting to return a value. And in this case, we're not going to use one and instead use this as something to hold basically a bucket of code that we want to execute once. Now, a function is typically called in code when you're going to perform a little chunk of code over and over. And it prevents us from having to do things that are repetitive, and it also makes it easy to change later on. Now, in this case, we're going to use setup to run everything that needs to run once before we do everything else, because the distinction is the loop function, which is going to be the second thing that we add. Now, the loop function is going to run over and over. And its job is to basically be the continuing logic that's always going and searching for whatever it is we want it to do. Maybe read a sensor, maybe output a certain amount of power to the LED to make it turn on or off. Either way, this is what's going to be running continuously, and then we can kind of store functions up above it in order to allow for some minimal code to be running all the time, and then if we hit a trigger, it to call some sort of function that will execute a little block of code. All right, so that's we're kind of almost getting to a lot, but now we have two functions. Both of them are voids, which means we're not expecting anything. And we know that this first one is for setting up what we want. So maybe in this case, we're going to turn the pin mode into output. And then this is going to be for running code that we want to execute constantly, basically figuring out what we need to be running, probably just turning the LED on and then switching it back off. Okay, so as I said, the first thing we need to do after we add a open bracket is go ahead and select the pin mode for this particular pin. So pin mode is a special function. You can see it light up, and you need to make the M capitalized. And if you do that, then this is a function that's expecting us to give it two parameters. The first is going to be LED, which is the variable that's holding, in this case, the number 3. And the second is output. Now you can see that went blue. I need to make sure that this is in all caps because it's a special word that lets Arduino know that we want to have this pin available for sending output to. Now I'll go ahead and end the line like this. And then this is actually all we need to do in order for our setup to work. So unless I've made a mistake, which I'll check for in a little bit, this should do everything we need to set the pin to output mode and let us put power onto it whenever we want. So now within the void function of the loop, let's decide what we want to add next. Now, the first thing is going to be to actually turn the pin that is controlling the LED on. So let's call another function called digital write. Now, digital write doesn't work if you haven't first set the pin to output mode. So that's why it was important to do this first in setup. Now you can see it turn orange again, and that means that Arduino recognizes what we're trying to do and is ready for us to supply it with some more information. Now here, I'm again going to say LED, because that's the LED we want, or that's the pin that we want to interact with, and then high in all caps. Now high is telling it to supply power to that particular pin, which in this case will turn it on. Now if we just kept it high, it would turn on and it would never turn off. So after a little bit of time, we want it to turn back off again. Now this is where we get into delays, and a delay is critical because microcontrollers work really fast. If we didn't put a delay here, or if we kept it too short, it could basically turn on and off so quickly that the human eye couldn't tell the difference. And that's not desirable because we want to be able to tell whether or not what we're doing is working. Instead, what we'll do is add a delay here to make it so we can perceive the difference of it being on and off. So first we'll write delay, and then we'll give it a time period, and this is in thousandth of a second. So 1000 should be 1 second. Now we're going to do another digital write, and this time we're going to turn the LED back off. Now with a final end of the line here, we should be able to go back and close all the lines with a semicolon to make sure that anything that is just command hanging out there and isn't a function is closed. We've got one there, there, and there. So in order to check this, we can press the check mark in Arduino, and if we've made any mistakes, it should pop up and tell us that we've made a mistake. And in this case, it looks like I've coded everything right the first time, which has almost never happened. So this is a pretty compact little program. We don't have a lot that we're doing, but we're turning it on, and as you can see, I've forgotten, actually, we want to do a second delay here for another second to keep the LED off for a second as well as being on. Otherwise, this would have turned it off for virtually a millisecond or something like that, and then it would have turned right back on and we never would have noticed the difference. So adding that, it still looks good. And the final thing we'll need to do is make sure that our device is plugged in, and then we have the port selected. Now, whatever board we're using, we'll need to go into Tools and then select the correct board. And in this case, I'm just using an Arduino Uno, but you might be using a Node MCU or something else like a D1 Mini. Any of these should work, you just need to make sure you have the right one selected. Then when it's plugged in, you'll go ahead and select the correct port. And I'm not detecting any right now because it's not plugged in, but as soon as I do, I should be able to just press the upload button and send this code directly to our Arduino. Now, let's go ahead and take this micro USB cable and plug it into our device so we can test our Arduino code and see if we have it working. Now you can see the LED is not turning on. So in our Arduino, that's expected because we haven't pushed our code yet. So first we'll click on Tools, confirm that we see the board under our port settings, which we do. And now we can click on the upload key in order to send our sketch to the Arduino. Now, after this goes, we should, there we go, see the LED light up, which is perfect and exactly what we expected. Now, let's make a quick modification just to see what it looks like on the LED. If we want to go back into our code and modify, let's say, the delay, we can go ahead and do this. And then when we push upload again, you'll see that as soon as it finishes pushing, suddenly the LED is off more than it's on and it's blinking a lot faster. Now, if this was a speaker or something else, you could modify the parameters just the same way. So it's really easy to take an output like an LED and control it in Arduino with just a couple modifications and a couple lines of code. After you finish with this, you can also go ahead and add inputs. So maybe if you have a sensor or something else, you can rig it so that it's able to identify when something's nearby and cause something like a light to go off. Now, whether you are using this $45 setup or you're using something like the $6 Node MCU, it's really easy to get started. And I definitely recommend this for anyone who is interested in hacking or just interested in electronics. While microcontrollers can't do everything a Raspberry Pi can do, they're still incredibly useful because they're simple to program and easy to create prototypes that don't exist and might not be available for sale anywhere. With the right input and output, you can design logic to do basically anything. So learning how to program an Arduino is an incredibly useful skill for any hacker. If you want some more ideas or you need some troubleshooting, you can check out the link in the description for more ideas on what you can do with a microcontroller in regards to hacking. That's all we have for this episode of Cyber Weapons Lab. Make sure to like, comment, and subscribe. And if you have any thoughts or feedback on the show, send me a message on Twitter because I'd love to hear from you. We'll see you next time.